Okay, to start with, do covalent bonding in chlorine molecule Cl2 and show it for methane also, CH4. This is methane. This is the simplest carbon ka compound that we'll be looking at. Are, Shana, Arshia, Aryan, what happened? I have to turn your video off. Like just like start writing.
No, I went to get my notebook. It was ups.
Aryan, where are you? Quickly get it done. So once I see that you guys are able to do it, we'll go to the next part. If anyone's not able to figure it out, abhi batao, so we'll discuss it. Otherwise, yeah.
Do we send a picture?
Yeah.
Yeah.
So if you've done both, send both at once. If you're not confident, if you're not sure, then send one at a time. Okay. Yeah. So Akshanya, Arna, Swayam video is not on yet. You just asked, can you switch off your camera? Why? What happened?
Me?
Not you, Dakshanya. Phone heated.
On the phone, yeah, the battery.
Okay.
I dropped it in water like a month ago. So every time I use it a lot, it's getting heated up.
What happened to computer? Not a.
I'm out of Mumbai, right? So the
You
computer that it was my aunt's computer, but for some reason the Zoom isn't responding.
Okay. Okay. Arna, what about you? Where are you? Yes. Okay. So elemental carbon, do you know how carbon exists? Elemental state mein? As pure.
Yes, ma'am, graphite, diamond.
Diamond, yes. With where else?
Ma'am, graphite.
Graphite, yes. Do you know any other forms?
Ma'am, coal.
Coal is a good example, yes. And there is one more form. It's called Buckminster fullerene.
Ma'am, isn't coal like impure?
Yes, it is. We'll talk about it. Okay. So these are different forms of elemental carbon that you can find naturally occurring. इसमें से diamond, graphite and Buckminster fullerene, these are properly pure forms of carbon. Coal may you find carbon, yes, elemental carbon, yes, but this is impure. Like along with carbon, it's a bunch of other things. It's a mixture of carbon with a few other things. Can be sulfur, can be nitrogen. It depends on where you find that coal and how you get it. But yes. So coal is the impure form. Diamond, graphite, Buckminster fullerene are forms of carbon that you can find in nature. Now, what is the difference between diamond and graphite? this, let it be, because we like you guys are you don't know about this yet, but diamond graphite you're familiar with. So why do we have two different forms of carbon? Like, what's the difference between them? Yeah, Aryan.
Ma'am, so they're like basically they're known as allotropes of carbon, and diamond is formed in high pressures and like heat, and while graphite, now I don't know about how it's formed, but I know that graphite is a good conductor of electricity, and yeah, that's it.
Yeah, so you're right, they are called allotropes of carbon. And the reason, part of the reason is in what you said, like their formation. So all the difference in properties, like diamond being hard, shiny, graphite is like soft. It's also lustrous, but it's not like crystal type of shiny like diamond is, right? And graphite is a good conductor of electricity, diamond is not. So all this difference in properties comes from the fact that they have um, even though they're made up of carbon, the way carbon is arranged is completely different. Okay, so the official definition of allotropes is um, the like when an element exists in multiple physical forms. And I'm not talking about just solid, liquid, gas, but yeah, you can see in terms of their melting point, boiling point, hardness, physical properties itself is completely different, even though chemically they are like the same thing. So those multiple forms are called allotropes. Just a name given to, oh yeah, these sort of categories that you can find. And allotropes is not exclusive to carbon, like diamond, graphite, Buckman's, like buckyballs, these are allotropes of carbon. But you also find allotropy in sulfur. So sulfur ke allotropes, you call it alpha form, beta form, also called rhombic monoclinic, in case you've heard of it. If not, that's okay, just names. Phosphorus also has different allotropes. This you may or may not have heard of. Have you guys heard of like there being red phosphorus and white phosphorus? Two different forms, anytime, anywhere. Swayam is nodding. Where did you hear of it?
No, I don't know, but like I have just like heard about it. I
You've
don't
heard of
remember
it.
exactly.
Do alag alag.
Yeah.
Yes. Yeah, now it's up.
Ma'am, like red phosphorus is used in like matchsticks
Yes,
because it's like very flammable.
that is correct. White phosphorus is also very, like, I think white phosphorus is even more flammable than red phosphorus. So I don't know if you guys had it or not. Do you remember the concept of spontaneous combustion? No? नहीं किया 7th 8th में?
Yes, ma'am.
Some of you know it, others you don't know it. It's okay, never mind. So basically, white phosphorus is the kind of substance, jo, if you just like wave it in air, it reacts with the oxygen in air and it like catches fire on its own. You don't need to.
Ma'am, what was the name again?
It's just white phosphorus.
No, the reaction name.
Oh, that's called spontaneous combustion.
Oh, I don't know.
That's okay. Just a moment, guys. All right, sorry. Yeah, so like it's not just carbon, so many other elements also have like different forms that they exist in nature. It all boils down to how they are formed that decides, okay, how are the atoms arranged. Similar to solid, liquid, gases, like chemically they may be the same thing, but it's just the arrangement of atoms mein wo difference aa raha hai na, solid versus liquid versus gas. That way here also solid versus liquid versus gas, not solid, depending on the arrangement of how the carbon atoms are arranged, or how the sulfur atoms are arranged, or how the phosphorus atoms are like bonded to each other, it gives rise to different physical forms. So this kind of category, all these physical forms, they are called allotropes. I'll just share the chapter notes. So write down the definition of allotropes from this. Here, allotropes, this is like the proper definition. So note this part down. Two or more different physical forms in which an element can exist is called its allotropes. So each of these forms is one allotrope. And then each allotrope has its own name for identification. Okay. So let me know once you finish noting, and then we'll talk about like diamond, graphite specifically, each of these allotropes. Arna, you've sent the structures, no? Okay. Ethane, methane, these are the structures, correct, but I was also looking for the dot structure, dot representation. Okay. So do it after class and send it.
Yes, ma'am. Like dot, I couldn't understand.
No, like we've done it in the previous class, no? This like represent the electrons in the form of dots and
Oh,
all of the valence electrons. That way. Dots or crosses. Okay. Megha, I'm assuming you finished noting. Yeah. Others also let me know. And where's your video, you guys? Arshia, Swayam, Shana. Don't just vanish off, no. Like I don't have like I shouldn't have to call each and every the names after every sentence.
No, actually, someone was there at the door.
Okay, why you've like masked your background also, दिखेगा नहीं कुछ.
So I had gone.
You weren't there, तो बता के जाओ ना. Don't just like go off. खत्म हो गया लिखना. Like Dakshini, have you finished writing? I can't see you. You have to let me know.
Yes, ma'am.
Okay. Cool.
Ma'am, can you show the previous slide for 1 minute?
Previous, this only, the whiteboard.
Yeah.
Okay, so let's bring up. Okay, so what are these allotropes? Where does this like, if the structure is different, what do you mean by, the structure being different? Shana, do you have a question or you finished writing? Oh,
Finished writing. Sorry.
cool. So when we say there's a difference in the structure, actually I'll describe the structure first and then I'll show the 3D representation. In the case of diamond, how the carbon atoms are arranged, actually diamond is much simpler compared to graphite. Okay, so suppose you have a carbon atom. What is the valency of carbon? 4. How many covalent bonds does it need to form? How many total covalent bonds? Yeah,